Hi, welcome back to the course. In previous session, we have seen in detail about deep learning and computer vision, how the classification problem completely solved by the deep learning, how the object detection segmentation problem completely solved by the computer vision. So these are the things we have seen in the previous sessions. Now we are going to see in detail about generative AI. What is generative AI? As the name mentioned, generation, previously deep learning and computer vision, that is essential for identifying, classifying the object. But if you want to generate an object, generate image, so in this scenario generative AI used. So in this video we are going to see how generative AI started, how it's evolved, and what are the challenges it faced, and how generative AI is shaping the future today. In 2014, the birth of GANs, Generative Adversarial Network. This is the major invention that initiated the possibility of generating an image. So in GAN network, there are two neural network is there in the GAN technology. One is the generator and another one is the discriminator. Generator generates the fake data, and discriminator, it acts as a judge. It finds whether the generated data is real or fake. So these two things try to act as the minimax game. Like generator keep on generating fake data and try to fake the discriminator, and the discriminator try to identify whether it's a real or fake. In the meanwhile, while training, generators can able to generate the data related to the real images. So this is the generator and discriminator part. As I said, generator is essential for generating the fake image, and discriminator takes care of judging the image is real or fake. For example, in layman terms, consider the painter trying to draw the cat. For example, painter will be the generator. Instead, he draws the cat, he tries to draw the dog. What discriminator does, it judges the painter's work and it tells that it's not the cat, it's the dog. So like that, keep on iteration happens. The painter, the generator keeps on improving his work, and somehow it comes to the cat drawing. So like that, the minimax game happens between the generator and discriminator over the iteration and training. Even though generator tries to fake the discriminator, during this both combination work, during iteration and training part, the cat will be generated at the end. So this is the minimax game happens between the generator and the discriminator. This both neural network will be trained for huge number of images, and then during training it can able to learn and generate the images as we want. The main challenge in the GAN is that whenever it does generate a discriminator based on minimax game, sometimes it has some limited capability of generating. Like for example, it try to draw the the final, our goal is to generate the cat image. It start faking from drawing the dog image, for example, and then while evolving it, sometime it failed to nearing the cat image generation. Like that, while training, it has some limited capability. It will not generate much samples, and it not evolve and improve while training. So this is the one of the problem occurs at the GAN when we're training on bigger level data sets. This is a major challenge. And in the second stage after GAN, and around 2015, the birth of VAE, variable autoencoder, was invented. Like in this invention, comparing to generative adversarial network, the VAE it based on the encoder and decoder architecture. For example, it takes the cat image and it decodes the cat image into some kind of 1D vectors, and then he will put this kind of 1D vectors into some latent space. Okay, and then decoder from the latent space, the clubbed 1D vector data, it tries to reconstruct. Okay, the decoder part try to reconstruct the 1D vector data which is distributed around the latent space, and the reconstruct data back to the cat. This is the encoder part, which is original cat image to the some kind of vectorized data which is spread over the latent space, and decoder will take over of from latent space to cat image. Like variable autoencoder works this kind of principles. Based on these principles, during training, encoder and decoder works on from original image to the kind of latent space distribution, and then decoder from distribution to the original image. Based on the bigger training and bigger iteration or for the bigger level data sets, the variable encoder outperforms very well comparing to the GAN method. And then we saw now what's GAN and what is the VAE. And then after 2016, to 2020, there are a lot of improvisation happened in the GAN. As we know that GAN has some challenges, like while training, sometimes it will learn, it will not generate the samples what we want. It will be limited number of samples only generated. To solve this problem, there are multiple new technologies added with the GANs. For example, conditional GAN invented around 2017, and then cycle GAN, style GAN, many different kind of conditional GANs came into the place. For example, conditional GAN in the sense, previously we generate the image it can be anything, but we can condition it. You can only generate the dog, you should only generate the cat, like the condition we can add while generating the image. So this kind of condition can be achieved with help of conditional GANs. And then cycle GAN came. What happens now? For example, if you want to transfer properties of one object to another object, for example, if we take cow image, if you want to transfer the cow image into the horse image, or else cow image into dog image, like that style kind of transferring one object to the another object, this kind of transfer based thing happens with help of a cycle GAN. And then style GAN came. It is one of the biggest invention that generated by the invented by the NVIDIA's team. What happens now? Previously we can able to generate based on the conditions. Now we can add the styles to it. We can improve the face color, we can change the eyes, and we can change the face dimension, we can change the dress color, and then different parts of our body, different parts of the image. Now apart from the adding condition to the image, now we can also change the styles inside the image. So this opens up, we can generate any kind of image, any kind of styles which is possible with the help of the style GAN. Nowadays you can see in the social media, when we upload our image, like different facial alterations, different kind of hairstyle, different kind of dress, we'll be seeing our image in Spider-Man's image, lot of style changes and everything happen. This is because of the style GAN invention. And then in 2021, one of the major invention happened, that is the invention of diffusion models, that is called stable diffusion. What is stable diffusion? As we said in variable encoder decoder, that will be encoder part and decoder part. Same like in stable diffusion part, there's a forward pass and a reverse pass. For example, maybe it's a forward pass, same like that in stable diffusion, it is the forward pass and backward pass. What happens in forward pass? Like in forward pass, it will take the image and then it will keep on add the noise to the image, and then it will make the image to the pure noise. Okay, and then what happens now? In backward pass, it will try to replicate the from pure noise to image, it try to reconstruct the image. So this happens in the forward pass and backward pass, same like in variable encoders. But in variable encoders, it will compress the data into 1D form, it will put in the latent space, and then it try to reconstruct in the decoder part. But whereas here complete noise based thing, we will add the noise in the completely pure image, and then we'll make at the pure noise, that is the forward pass, and then pure noise to the original image is the backward pass. In this architecture, the better kind of generation and better kind of image quality that can be achieved with the help of the stable diffusion method. But in challenge was in stable diffusion, for generating high quality images, there are a lot of computation was needed and a lot of time taken was happened, so that ultra high level quality images we couldn't be able to generate. To solve this problem, for example, in variable autoencoders, we have seen that there is a latent space, right? The same technology, that latent kind of distribution, that is combined together with a stable diffusion, that is now invented as a latent stable diffusion. So this is a very game changer. This enables so now the original data added with the noise, and then that added noise and everything compressed and put in the latent space, and then again in backward pass pure noise to the original image. But what happens now, due to data compression, that latent space added to the stable diffusion, now we can able to process the image, generate the image at a shorter time, and also this enables the we can able to generate the high quality of image. So this is possible because of latent stable diffusion invention. So this stable diffusion and the latent stable diffusion are around 2022-2023, and then the researcher wants to know why only image, why can't we image 3D part of the image, and then why can't we generate video, why can't we generate text, and why can't we generate audio? To solve this problem, the inventors came up with in 2023 to 24 came up with invention called multi-model generation. So it's a very big game changer. So it is a combination of in previously when we talk about stable diffusion, latent stable diffusion, during stable diffusion and stable diffusion times, no, OpenAI came up with some clip models where no, it combined the transformer model and then text to image conversion. Previously we only generate the image, that with combining the stable diffusion and this kind of generation model with the transformers, it enables us to generate the image with the help of text-based image, text-to-image conversion, which was successful with the help of combining the transformer with this generative AI techniques. And then what next? As I told, there's a multi-model generating image, video, audio, and what else? Text. So everything is possible. The researchers came up with multi-model generative AI invention, so that it combined with the transformer along with the all the generative AI models. Now we can able to generate image, text, audio and video with help of multi-model AI models. Now you understood how generative AI started from GAN, how it's now trending the future, shaping the future with help of multi-model AI that generating not only image, video, audio and text. So this is the roadmap of completely generative AI. Hope you enjoyed and learned how generative AI started, how it evolved and what are the challenges faced in middle, how multi-model AI is shaping the future now. Thank you so much.